Hey guys, so this is homework 7.5 and this is on an introduction to rational functions. Rational functions are really just the ratio between polynomial functions. They take on interesting properties because of their interaction between the numerator and the denominator. So here's an example of a rational function. F of x equals x plus 6 divided by x minus 3. Do you notice it's set up as a fraction? That is how rational functions are set up. So first we're going to find the y-intercept. So if you recall, the y-intercept is where this rational function or any function crosses the y-axis. So at the y-intercept, the value of x is 0. So what we're just going to do is we're going to replace all the x's in the equation with zeros, and we're going to simplify. So I'm finding f of 0, which means in the top it's 0 plus 6, and in the bottom it's 0 minus 3. So then that simplifies to positive 6 divided by negative 3. So f of 0 equals negative 2. So that means the y-intercept is at negative 2. Now we're going to find the x-intercept. This is a little different because of the fact that a rational function is set up as a fraction. So the only way for us to find the x-intercept in any case would be to find when the y value is 0, meaning the equation is set equal to 0. But in order for a fraction to equal 0, it would mean that the numerator equals 0. Because if the denominator of a fraction equals 0, that does not make the fraction 0, it makes it undefined. So when we find the x-intercept specifically for rational functions, we actually are just going to set the numerator equal to 0, because again, the fraction will equal 0 when the numerator is 0. So I set x plus 6 equal to 0, and now I am isolating x, and the x-intercept is actually x equals negative 6. Okay, so this is the same example, continued, and now we're going to determine the values that make the function undefined. So like we just said before, the function is undefined when the denominator of the fraction is equal to 0. So now I'm going to set the denominator x minus 3 equal to 0, and I'm going to solve for x. So I would add 3 to both sides, and I get x equals 3. This is the only value that makes this function undefined. State the domain of the function. Okay, so for rational equations, because they, again, are set up as fractions, if we have any type of variable in the denominator, we need to make sure that that doesn't cause the denominator, the whole denominator, to equal 0. So in order to determine the domain of a rational function, we need to figure out if there are any values that are going to make the denominator 0. And we actually just did that when we found the undefined values in part C. So now that I know that when x is 3, it makes the denominator 0, that means that the domain is actually x, such that x is an element of all real numbers, but x cannot be 3 because, like we said, that just makes the fraction undefined. Okay, here's another example. This example is h of x equals x plus 5, all divided by 2x squared plus 11x minus 6. Again, I know this is a rational function because it's set up as a fraction. So first we're going to state the values that make the equation undefined. So like we said before, a fraction is undefined if the denominator is 0. So I'm going to set the denominator equal to 0. 2x squared plus 11x minus 6 equals 0. So now it's a little bit different. It's not just a matter of isolating x. Because I see that this is a quadratic, I'm going to have to try to factor to solve for 0. Because when I set a quadratic equal to 0, the only way to solve for 0 would be to find the roots. Okay, so first thing I look for when I factor is I look for a GCF. And I don't see a GCF here. And I notice that there's a leading coefficient of 2. And in that case, that tells me that I'm going to have to use the garbage method. So I'm going to multiply this a term 2 by the c term negative 6, and that gives me negative 12. So now when I set up my two binomials, I'm going to keep 2x as the first term in both binomials. And now I'm going to think of two numbers that add to 11 and multiply to negative 12. So let's see, add to 11 and multiply to negative 12. Well, I think I can use 12 and 1. And since it has to multiply to a negative, one's going to have to be negative, one's going to have to be positive, and it has to add to positive 11, so the 12 will have to be positive. Okay, so 2x plus 12, 2x minus 1. Now remember I used garbage method, so that means that one of these or both of these binomials will have garbage, and I see that the first one has garbage, and I'm going to divide out that 2. So I have x plus 6, and I have 2x minus 1 equals 0. So now I set both of those factors equal to 0, and I end up with x equals negative 6 and x equals positive 1/2. So now part B asked me to state the domain. So like we said before, rational functions only have restrictions in the domain if there is a variable in the denominator, because that variable could cause the denominator to equal 0. And in part A, we just figured out what values actually do make the denominator 0. So we found out that if x is negative 6 or if x is 1/2, that will cause the denominator of this fraction to be 0, which will then cause it to be undefined. So that means that negative 6 and 1/2 cannot be part of the domain, but all other values can. So I would say that the domain is x, such that x is an element of all real numbers, meaning it can be any number, except x cannot be negative 6 or 1/2. Okay guys, that's all for now.